Okay, this is discussion 5 on page 35 in the packet about how you find the limiting reactant and what gets used up and what's left over and all that good stuff. Okay, all right, so the first thing we're going to do is we're going to think about this a little bit. Okay, balance the equation showing hydrogen and oxygen forming water. All right, so I'm going to balance that, and it's going to become 2, 1, 2. Okay, that's a pretty easy one. And the question says, if there's 4 moles of hydrogen gas and 4 moles of oxygen gas reacting, how many moles of water can be produced? Okay, make a drawing that represents the reaction container before and after the reaction. Okay, so before, I'm going to have 4 moles of hydrogen. Okay, note that this is not the coefficient, right? This is how much I actually have, because now we're going to get to where things aren't exactly perfect. Okay, and I'm going to have 4 moles of oxygen. Okay, and I'm just going to represent a mole as just one set, right? Just to keep it easy. Okay, so I have 4 hydrogens and 4 oxygens. Okay, and I want to know how much water I'm going to be able to make. So you want to think here, I need to get 2 hydrogens and 1 oxygen. So if I take 2 hydrogens and an oxygen away over here, then I can get a water. Okay, if I take 2 hydrogens and an oxygen, I can get another water. Okay, 2 hydrogens and another oxygen, give me another water. And then 2 hydrogens, another oxygen, give me another water. Okay, and then what happens over here? Well, I'm out of hydrogens, right? I have no more hydrogens, so that means the reaction is complete. I can't get any more. Even though I still have some extra oxygens, I don't have any more hydrogens, so I can't make any more water. Okay, so this is the point where the reaction's going to stop. All right, and we can see that I'm left with 2 oxygens are left over, and I've made 4 waters. Okay, and I have 0 hydrogens left. Okay, so how many moles of water can be produced? I'd be able to get 4. Okay, which reactant is in excess? It's the oxygen, okay, because there's some that is left over, right? There's no more hydrogens left, but I do have some oxygens left, and there are 2 moles of O2 left, okay? All right, so that's the idea behind the limiting reactant. It's not going to be perfect. Somebody's going to run out first, and once you run out, then you can't make any more, right? Like if I have peanut butter and jelly and bread, and I want to make sandwiches, it doesn't matter if I have half a jar of peanut butter left over. If I run out of bread, I can't make any more sandwiches. Okay, that's the idea. Okay, so then peanut butter would be the excess, bread would be the limiter. Okay, all right, so let's see what it's going to look like if we make a graph. This is actually my favorite part. I really love this. Okay, all right, so on this x-axis, we're going to do the progress of the reaction. And it doesn't really have a unit. It's just sort of like as time is passing. Okay, so I'm just going to spread it out a little bit to show that the time is passing. Okay, and then up here, we're going to have moles. Okay, and the most that I have anywhere is 4. So I'm just going to split apart my thing so that it's a little bit nicely spread out. Okay, you're going to have to just have a little practice with this, and you probably should use a pencil. Okay, all right. Okay, so I had hydrogen, was in red. Okay, so let's think about our hydrogen. I start with 4 moles of hydrogen, and then every time the reaction completes, I need to use 2 of it, right? That's coming from my coefficients, right? It takes 2 moles of the hydrogen for every cycle of the reaction. Okay, so at the next time, I'm going to be down to only 2 left, and then another time passes and I'm down to 0. Okay, so my hydrogen line is going to look like this. Okay, so I started with 4 moles, okay, and I used 2 every time. Okay, that's coming from my coefficient. So if I want to write this as an equation of a line, it's going to be a y equals mx plus b. Okay, the slope is -2 because I'm losing 2 moles each time, and the y-intercept is 4 because that's how much I started with. Okay, let's look at the oxygen. Okay, the oxygen also says it started with 4, but he only used 1 every time. That's from the coefficient in the equation, right, in the 2, 1, 2. Okay, so the oxygen's also going to start at 4, but every time the reaction happens, he's only losing 1 mole. Okay, so this is really hard to draw. So his line is going to look like this. Okay, right? So in an equation, I would say y equals, he's losing, so negative 1x, because he's only losing 1 every time, and he started with 4. Okay, now let's look at our water. What's happening with the water? Okay, the water starts with nothing, right? Because it's the product, all right? And it's going to gain 2 every time, according to the coefficients in the equation. Okay, so after 1 time period passes, there's going to be 2 moles of water. When another time period passes, there's going to be 4 moles of water. Okay, so water's line is going to look like this. All right, and he's gaining 2 every time, but now it's a positive because he's gaining plus 0. I'll just go ahead and write it because he doesn't start with anything. Okay, so this is what the graph of the reaction progress is going to look like. Okay, now, what do we do about this? All right, you can see here as time is passing on this axis, right? I start with no water, and then the hydrogen gets to 0 here, and the oxygen doesn't get to 0 until here, okay? So I can see from here that hydrogen is going to be my limiting reactant because it ran out first. In the progress of the reaction, it hit 0 first. Okay, so hydrogen is going to be the limiting reactant. Means he's going to run out first, okay? Once the hydrogen runs out, the reaction stops because it can't make any more water because you're out of hydrogen. So we're going to draw a vertical line here. Okay, right? And that is going to show me when the reaction stops. Okay? All right, so let's see what else this graph can tell us. If the reaction stops at this point, okay, water is going to be at 4. My oxygen is still at 2, right? Because he's the leftover guy. And then my hydrogen is at 0 because he was the limiting reactant. He's the reason the reaction stopped because we ran out of hydrogen. Okay, so I can see in this reaction, the hydrogen will run out first. I'll get left with 2 moles of oxygen, and I'll get left, or I'll make 4 moles of water. Okay, all right, so let me go to the next page. Okay, sorry about this dumb thing in the screenshot, but whatever. Okay, all right, okay, so now next page, what's going to happen? Okay, now let's kind of work it through like the way we're used to seeing it. So my ratios, okay, from the first page still are going to be 2, 1, 2. Okay, molar mass, I trust you can find that. Okay, and then 18.02 grams per mole. Okay, convert mass to moles if needed. We don't need this because it was given, right, that I had 4 moles. I was given 4 moles here and 4 moles here to start, okay? But these were both given in moles, so I don't need to convert from mass to moles, all right? Particle diagram in a perfect world, right? Every 2 hydrogens I get combine with 1 oxygen to make 2 waters. Okay, so this is like what the reaction looks like if it's perfect and everybody gets used up. Okay, I take 2 moles of hydrogen for 1 mole of oxygen to make 2 moles of water. All right, and then let's look at the BCA table. Okay, all right, so before I know I was given 4 moles of hydrogen and 4 moles of oxygen and no product. Okay, that's what I started with, right? That was the y-intercepts of the graph. That's what was given. Okay, now there's a couple different ways to do this. I prefer to use the graph to decide who was the limiting reactant, but I'll also show you mathematically in a minute how you can do that, okay? So according to the graph I just made, I know that it was the hydrogen was the guy that got all the way used up, okay? So that becomes my starting point for the rest of this, because that's the one I know is going to get all used up, okay? Then I'm going to multiply by my ratios. I have 2 hydrogens to an oxygen, okay, and 2 hydrogens to 2 waters, okay? So here I can see if I have 4 moles of hydrogen times the ratio 2/2, that's going to still leave me getting 4 moles of water, okay? And here -4 times 1/2 is -2. Okay, this is -2. So if I started with 4 moles of oxygen, I only used 2, so that's going to leave me with 2 moles of oxygen. Okay, this is the one that we call the excess. This is the one that's left over. Okay, because that's what I'm left with. I used up all the hydrogen. I've got 2 moles of oxygen left, and I have 4 moles of water. Okay, which as you can see from our graph, that's exactly what we found. Okay, convert mass to moles if needed. We don't need to because all they asked for was moles of water. Okay, if they had asked for grams to water, then we'd have to use the molar mass, but they did not. Okay, now, whoa, stop. Okay, now where can I do this? Okay, I'll just try to do it down here. I know this is kind of messed up, but okay, all right. Now, dimensional analysis, if you want to solve it without all the graphs and stuff, you have a couple of options. Okay, so the first thing is, I know I start with 4 moles of hydrogen. Okay, we'll assume that all the hydrogen is used up. Okay, and I know from my ratios that 2 moles of hydrogen make 2 moles of water, so I know I'm going to get 4 moles of water. Okay, if I use up all the hydrogen, I'll get 4 moles of water. Okay, or what about the oxygen? All right, so I have 1 mole of oxygen makes 2 moles of water. So if I was able to use up all the oxygen, I would make 8 moles of water. All right. This becomes the limiter because this is the one that makes the least, right? I can't make 8 moles. That'd be great, but I can't because the hydrogen can only make 4 moles. So this guy becomes the limiting reactant because he's going to run out first because he can only make 4 moles of water. All right, so I know at the end, I'm going to get 0 moles of hydrogen and 4 moles of water because that's all that I can make. I can't get to this. That's too much. All right, so I know I'm going to get 4 moles of water and 0 moles of hydrogen at the end. Okay, then the other thing it'll ask is, well, how much oxygen is left over? Okay, well, if I start with 4 moles of, If I start with 4 moles of hydrogen, because that's the guy that's getting used up, I want to see how much oxygen is that. Okay, so 2 moles of hydrogen, 1 mole of oxygen. Okay, means there are 2 moles of oxygen. Okay, there are 2 moles of oxygen that get used. This is probably kind of a bad example now that I'm looking at it. Okay, 2 moles of oxygen are used, so then that means I'm going to have 2 moles of oxygen left over because I started with 4. Okay, and then you can also change any of this to grams if you want. All right, and then that's how you do a limiting reactant problem.